Hey everybody, Brian Mullen here. I'm working on my first Moonlight experiment. Today is actually March 22nd, 2016. It's supposed to be a clear night tonight, so I figured I'd do it tonight. And maybe tomorrow if it's just as clear. It's not too windy, but what I've decided to do, actually Mr. Thrive and Survive gave me this idea, is have my candles in a fish tank. I have this old fish tank to help block the wind, and obviously it's glass, so it allows moonlight to shine through. And the idea here is that the candle on the left will be shaded by this piece of plywood, and the candle on the right will be exposed to the moonlight, and we'll see which one burns down faster if it makes a difference. The moon will be rising over here above these trees to the east around 7:11 p.m. It's about 6 p.m. right now. So in about 2 hours I should have a pretty solid moon. It's 99.6% full or something like that, so pretty much a full moon. And just for record keeping, the shaded candle is shoved into a 19mm socket, and the moonlight candle is shoved into a 3/4 inch socket. 3/4 inch and 19mm are actually interchangeable if you're ever working on a metric or American-made car, vice versa. Same with 9/16 and 14mm. So yeah, that's the basic experiment. And besides the candle, how much the candles burn down, I started thinking about this a lot. Put this back over here on my tripod, and well, I thought the best way to do it would be to actually measure the temperature of the flame. And to do that, the real way to do that is to have a thermal imaging camera, so I said, what the heck. I went out and bought one. Got a FLIR TG165. This thing is rad. Just turn it on. I now know my roommate is not a robot. He does have a human heat signature. And if you can see that, I should have a normal human temperature in Celsius. So I'm a human being too, just in case you're wondering. But playing around with this thing, I've found that any area exposed to moonlight is always at least 1 degree Celsius cooler than areas that are shaded. Now it depends on what you're looking at. You want to compare grass to grass, asphalt to asphalt, concrete to concrete. You can't switch between surfaces because they all heat and cool at different rates. So you really need something uniform. But I've been walking around the neighborhood in the evenings and early this morning playing with this thing, and areas in direct moonlight are always colder than the surrounding shaded areas. Always. It's pretty interesting. I think it's something we need to get some answers for, because if the moon is really reflecting the sunlight back at us, I don't understand how it could be cool. And then you get into energy flow and everything else. So that's the experiment. I'll be playing around with this thermal imaging camera and seeing where we can go from here. This is just the first experiment. I'm not expecting too much from it, but we'll see what happens. So I should be uploading some results in the morning. Alright, till then, peace.